Welcome back. In this video we will be looking at the tool setup section of the BenchEzy advanced settings. Okay, let's get started. BenchEzy version 3 advanced settings. Tool setup. In this section we have three areas which we will be looking at. The first area we'll be looking at will be the machine. This is basically a listing of what tools are loaded into each individual machine. Now, if you remember, we have 4 machines set up in this particular environment, and as I select a different machine, you can see here that the list on the right hand side changes. So going back to our rover B, we can see here that we already have the tools loaded. Now what we can do is, just to give you an indication of how quick and simple this can be, you can highlight your first tool, hold down your control button and go through and keep continuing to click tools. As you can see, that will then select all of those tools. You can simply then select load tool. As such, you therefore then have those tools added to your BSC rover B. But obviously we don't need to do that, so we will just take those back out, and again we can do the same thing again. We can hold our control button down and simply select unload tool. This section is very simple and straightforward. We just need to make sure that we have every tool loaded that is available in each individual machine. So for this exercise we'll simply add in this 6mm right hand cutter, which is not already loaded. Load the tool. As you can see, that is now loaded in. We can then go across and look at the joins area. We have quite a number of settings to do here. Again, these settings are duplicated for each and every single machine. We'll go back and look at our BSC rover B, and we will work our way through each setting one at a time. The first area is the clockwise rotation tooling. So what we're doing here is we're telling BenchEzy what tools we want it to use when it's doing a clockwise rotation machining operation. Now, for each clockwise rotation machining operation, we have a roughing pass and we have a trimming pass. So for our roughing pass, we would like to use the 18mm right-hand cutter, and we can obviously change that to use any of our tools that we've loaded up in the previous section. So we just, the 18mm right hand, we would like to make 2 cuts for each operation. So what that means is, if your substrate is 34mm in depth, BenchEzy will automatically make the first pass cut to a depth of 17mm, and then the second pass will cut from the 17mm depth through to the final depth of the thickness of the material. So if we were to say that we would like that to be done in 3 cuts, the first cut would go simply down to approximately 11mm. The second cut would go down to approximately 22mm, and then the third cut would go down to the full depth of 33mm. We then tell BenchEzy how much stock we would like to leave. Now, the stock is the amount of material that is to leave on the finished join line. So if we were to be doing a join operation, for example, we wouldn't like to have our roughing cutter finishing that machining operation at exactly the point where our finished join will be. So what we will be doing is, in this particular case, leaving 2mm of stock left on the join line. We would then tell BenchEzy how much through cut we would like. Now, the through cut is the distance from the underside of the workpiece to the bottom of the tool. So that in this particular instance, we're telling BenchEzy that we would like to go 0.2 of a millimeter below the bottom surface of the workpiece. So again, if we were looking at a 34mm substrate, our final depth of cut would be 34.2 millimeters, which means that we will be machining either 0.2 of a millimeter into our sacrificial sheet or 0.2 of a millimeter below the underside of our workpiece on a pod machine. The next section then is the trimming for the clockwise rotation tooling, and in this instance here we're going to use the 18 right-hand trim. We are going to do it in one pass. Now, you would normally have your trim cuts set up to be done in one pass. That way then you get one nice smooth edge on your machine line. You could of course tell it to do it in more operations, but you would be more inclined, I think, to just simply have that always set as one cut operation. We obviously want that then to finish exactly on the machining line as in the finished size of the product, so we would like to leave 0 stock, and then we have our through cut extra amount, which again is our 0.2. Next section then we've got our anti-clockwise rotation tooling, which is basically the same operations that we've just covered, except these are the anti-clockwise. So we've got our left-hand cutter here, as you can see, as compared to using our right-hand cutter. We still have 2 cuts. We're leaving 1.5 millimeters of stock in this instance, but we still have our 0.2 millimeters of through cut. For our trim operations, again anti-clockwise, we're using our 18 millimeter left-hand trim cutter, 1 pass, 0 stock left, and again 0.2 of a millimeter through cut. Now, the next section is to do with our join bolt machining. Now, a join bolt is basically broken up into 2 operations. We have the housing section, which is the area where the actual join bolt toggle sits, and then we have the trench, which goes basically from the center of the housing through to the join face. So basically for our housing operations, which of course are going to be pocket operations, we are going to use our BenchEzy 18mm right-hand cutter here. We want that done in one cut. For our trenching operation, for our join bolts, we are going to use our 12mm right-hand cutter, and we're going to do that with 1 pass. The thing to remember with any pocket operation is that if your pocket machining is only 10 millimeters in width, for example, it would be senseless telling BenchEzy to use a 12mm right-hand cutter because the cutter's bigger than the finished size of the trench. So the default width of a join bolt trench housing pocket operation within BenchEzy is actually set up to approximately 13 millimeters. So that means by using a 12mm right-hand cutter, we are slightly under the size of the trench, which means that we will get a very efficient pocketing operation. Next area we're going to look at will be extra join operation machining. Some people like to use biscuit grooves on their joins, and some people also like to ease their joins. So again, imagine we're joining 2 bench tops together that are 33 millimeters in thickness. We are basically butting 2 33mm surfaces together. By easing the join, we are, instead of butting 2 33mm surfaces together, we are going to butt for argument's sake, a 5mm section at the top of the join and a 5mm section at the bottom of the join together, and then the actual center area of the join will not be touched or touching. So this will obviously require a specialized tool to achieve that result. But if you would like to get that tool made, by all means you can then utilize a join easing. The same thing then would apply that with the biscuit grooving. We can do a biscuit groove on any of our joining operations, whether it be a mason's miter join or a butt join or a miter join. Again, depending upon our machine type that we're using, if we're using a nesting machine, it would have to be a very specialized tool, and you also would need to be very, very careful what settings you used here to ensure that there was no machine and tool crashing, you might say, because if your tool was that long that it was trying to cut or run through the sacrificial sheet all the time, well, obviously we're going to have an issue. Now, although we may or may not use this join easing or biscuit groove operations, we still have to set it up and give BenchEzy some information with regards to some tooling. So as you can see here, I've got my join easing tool set up as a 45-degree cone. Now obviously a cone is not going to be the right tool to use here, but I'm simply telling BenchEzy that's the tool I'm going to use, but when I actually do generate any machine code, I will already have the join easing option turned off. Now, the option to turn on or off the join easing or the biscuit groove is in a different section of the settings, which we will cover later. But just keep in mind that we need to complete this information and give it something. Whether or not we actually use these operations, if we don't use these operations, it doesn't really matter what we put in here because we're never going to use it. But if we are going to use it, we must ensure that this information is correct. The basic principles, again, of the operation sizes are the same as we've already completed. The number of cuts always defaults to 1. You can't change that with these two particular operations. The stock to leave, so because we're easing the join or we're doing a biscuit groove, we actually want that to be on the material side of the join line, not on the waste side, which is hence the reason that it's a negative value. From the top of the top to the ease, okay, so that's from the top of the top, which is the laminated surface of the top, we're going to come 4 millimeters. Then from the bottom of the top to the ease, we're going to be another 4 millimeters. So basically what BenchEzy will do in a combination of BenchEzy and AlphaCam, if the particular cutter that we have set up in our tools isn't capable of machining that distance in one pass, it will automatically do as many passes as it needs to fulfill that machining operation. It's basically a vertical pocket, you might say, instead of as opposed to a horizontal pocket. The biscuit groove, again, we want the stock to leave. We've set it -10 here, which means that our groove will be 10 millimeters in depth on the finished join line. From the top of the top to the groove, in this case, we're 3 millimeters. So from the laminated surface down to the groove, we have 3 millimeters. And then, of course, the width of the groove is dictated by the thickness of the tool that is being used for the operation. Now, we also then have these last two settings here, which is the amount of offset operation start and finish, which is expressed again as a factor of the tool diameter. What we're talking about here, let's use as an example our biscuit groove cutter. Let's assume that at the moment it is 80 millimeters in diameter. So what we're telling BenchEzy with this setting is that we want it to be 0.6 of 80 millimeters away from the start and the end of a joint. So that means that it will basically start the groove, in this case 0.6 of 80 millimeters is 48 millimeters. It will start groove 40 millimeters from the end of the joint and 48 millimeters from the start of the joint. Same then applies to the joint easing tool, assuming for a minute that our joint easing tool is 30 mils in diameter. 0.6 of 30 millimeters is 18 millimeters, so therefore the operation would start 18 millimeters from the start of the join line and then finish 18 millimeters from the end of the join line. The idea of this setting is so that we don't end up with a biscuit groove running through the rolled edge of our bench. That covers the join tool setup. We'll move on now to the cutouts. In this section here, again, we have settings for each and every machine that we have set up in our environment. Go back to our BSC Rover B. We have our basic cutout machining operations, which consist of sinks, hot plates, vanities, laundry tubs, and miscellaneous. We've also got our top trimming machining, which is the basically tooling operations that would be used, for an example, on the back of a bench. If we have a 600 wide substrate and we are going to machine a bench top that we want to finish at 500 millimeters in depth, we can get BenchEzy to cut that last 100 millimeters off the back of the bench for us while it's doing the other machining operations. So we then obviously have to be aware that some of these operations need to be done in a clockwise direction and some in an anti-clockwise direction to prevent chipping of rolled ends or rolled fronts or that type of thing. So that's why we have two tools in use here. Anything that has got to be done with a clockwise rotation, we'll use this tool, and anything in an anti-clockwise rotation, we'll use this tool. So now, first of all, we'll go through and we'll look at our sinks again. So for our sink cutout operations, I want to use the 18mm right-hand cutter. I want it to be done in 2 cuts. Again, that's the same principle as we've already discussed. We want stock to be left. In this instance, this setting would normally generally always be 0. If for some reason you wanted to have some sort of a special amount here, for whatever reason, you can have a value here. It does not have to be set to 0. Our through cut amount again is 0.2 millimeters, which we've already discussed. Now just quickly going through the rest of our cutout machining operations here, our hot plates, we are using our left-hand cutter. We are using our right-hand cutter again for our vanity cutouts. For our laundry tubs, we want to use our left hand again. And miscellaneous cutouts. Now, miscellaneous cutout could be anything from a pop-up power point in your bench to a bench-mounted rubbish bin. That's the sort of thing that will fit into the miscellaneous cutout category. Again, we've got our number of cut settings, stock to be left, and through cut settings for all of those particular type operations. Same thing again now with our clockwise top trimming machining. We want to use our BenchEzy right hand. Because it's a clockwise operation, it would be advisable to use a right hand rotating tooling, particularly when you have your setup over in this tools section here. We have a BenchEzy right hand cutter. We've said that we want it to be in a clockwise travel direction. So by using a anti-clockwise rotating tooling but traveling that in a clockwise direction, could lead you to some dramas. So what we do is we basically look for our clockwise rotation to be using a clockwise rotating tool. So hence the reason it would be a right hand. And then our anti-clockwise would be left hand. Same again, number of cuts, stock to leave, and through cut amounts. We also then, just in this last tool that we need to set up in this section, is for machining of window pieces. Now, a window piece, by my definition, is where our bench top has to extend to go to the wall from the rear of the bench into a window opening so that the bench top actually sits against or underneath the aluminium of a window. So for our operation here, we're going to use the 18mm right hand cutter, and we want that done to be in 1 cut. This is a pocketing type operation, whereas all of these other ones up here are all basically pure and simply single operations, whereas your window piece machining is a pocket operation. Now, what I tend to try and do is to alternate the tooling for each of these cutouts so that we're sort of trying to spread the wear across the entire range of tools in our machines. Because if we were to turn around and use our 18mm right hand cutter to do everything, all of these operations, it would get hammered. So by mixing it up, we might be doing a sink top, so that means that tool's going to get a bit of use. Our next kitchen top might be a hot plate, so that left-hand cutter will get some use, so that we're trying to spread the wear and try and make our tools stay sharp for a little bit longer. All right, that covers the tool setup section of our settings area. Make sure you continue watching the rest of the videos, and in the next video we'll look through at our machining operations. Thank you for watching. Be sure to continue to check out the rest of the videos in this series.